Hi, welcome to my video on piecewise defined functions, graphing number 2. Just more examples of piecewise functions with a few more extra concepts or types of functions that we can graph. And in this one we have the f of x is equal to negative x when x is greater than or equal to 2, x cubed when going from negative 2 to a 2, but not equal to negative 2, not equal to 2. And it's x plus 2 squared when x is less than negative 2. So let's look at each of these. Again, the f of x is a y, so we can have a y or we can have an f of x. So let's take the first one. Y is equal to negative x when x is greater than or equal to 2. Again, we can do a table of values, but when we look at this, I see that this is y equals negative x plus 0. So really, this is a line, linear, which has a y-intercept of 0, and it goes down. It goes down 1, right 2. So it starts at 0, going down 1, right 1. So it's going down from right here, but we have to start at 2. So remember, it's going to be a line. Start at 2, so x and y. So we start at 2 and it's going greater, so that's a 3 and a 4 and a 5, etc. So we take a 2 and plug it in here, we get negative 2. Take a 3, plug it in here, we get a negative 3. Plug a 4 in here, we get a negative 4, and etc. 5 gives me a negative 5. So this point 2 is included, so 2, negative 2. So 2, negative 2 is right here. So this point is included, it's not hollow, solid. So we got 3, negative 3 is right here. And we got, 1, 2, 3, 4. Notice that 5 is in the wrong spot. So the 5 should be right there. So that's a 4, gives me a negative 4. And we got a 5, give me a negative 5. So it's a line that's going down from this point. There it is there with an arrowhead. And this point is included. Now let's look at the next one. Y equals x cubed, and we're doing the cube over the interval of negative 2 less than x less than 2. And if you did the review, or I'm assuming you're in pre-calculus on piecewise functions, so you should know what x cubed is. Just to draw the x cubed, if you draw this grid, normally x cubed would be like this, coming down here and doing this. This is the basic graph for x cubed. So it's going through the origin, coming down from here, and so this graph right here is a part of this on this interval. So we take a negative 2 and we plug it in. So a negative 2 cubed is negative 8. And then we take negative 1. Negative 1 cubed is negative 1. Take a 0, and then we're going 1, and we're going to 2. So take a 0, plug in here, we get a 0 cubed is 0. Plug a 1 in here and cube it, we get a 1. Plug a 2 in here and cube it, we get an 8. So this graph, this is a piece of this curve. So we have negative 2, which is right here, gives me negative 8. So negative 2 gives me negative 8. But this point is not included because a negative 2 didn't say equal to. Negative 1 gives me negative 1. Negative 1, negative 1. Negative 1, negative 1 here. 0, 0 is here. 1, 1. 1, 1 is here. 2, 8. X is 2, y is 8. Here, again, this point is hollow, is not included. So it comes down from here, very similar, same as this, only it's restricted. So there it is, right there. Coming down to this point. There it is there. but instead of going with arrowheads on it, it's cut off from -2 up to 2. So there's the x cubed. And we have a third one, y equals x plus 2 squared when x is less than -2. And we look at a table of values on this function. So when I look at this, I see a parabola. So I see a parabola here. This is a parabola that got when x is -2, y is 0. So that's the vertex of this parabola. And so this parabola's this parabola is positive, because that's a positive. That means it opens up. So if you think about it, I have a vertex at -2, 0, and it opens up from there. So that means it's doing this. Without this restriction, this is the parabola that starts at the vertex of -2, 0, and moves upward. But this is a part of it. We're looking at the parabola part where x is less than -2. So there's -2. So what's the -2 going to give me? Put a -2 in here, I get 0 squared is 0. And we're going less than, so we're going to put a -3 in. We're going to the left. -3, -4, -5, etc. -3 here gives me -1 squared is 1. Notice that this, no matter what number I put in here, real number, it has to be positive, because a square is always positive on a real number. Put a 4 in here and I get a -2 squared is 4. Put a 5 in here, I get a -3 squared, which is 9. So I got -2 gives me a 0. -2 gives me a 0, greater than -2, so it's right here. Now, a little dilemma, we got a point that's not included and included. So let's make -3, 1. X is -2. Oops, sorry, no. I said -2, 0. X is -2, 0 is right here. My mistake. Again, not careful enough. I was plotting this point here at the origin. X is -2, y is 0 is right here. That's hollow because the -2 is not included. -3, 1 is -3, 1 is right here. -4, 4, -4, 4 is right here. That's -4, 1, 2, 3, oh, -1, 2, 3, 4, -4, 4. And again, when I did the grid, can't count correctly. So that's 1, 2, 3, 4, 5. I said that was 5. Now it's twice I made that mistake. And right here on the same grid, there must be something wrong with me when I made that grid up counting. And a -5 gives me a 9. So -9 is that's a 5. 1, 2, 3, 4, 5, 6, 7, 8. 9 is here, so -5 is a 9. Let's say it's going to be right here, close to it anyway. And so it comes up from here. So it's the left side of this parabola. There it is there. So there's the grid of that piecewise function. And again, these are 5 to -5. My mistake, apologize for that. Marking these out wrong. Okay. And we have another one, again, different types of functions. And let's graph this one. The f of x equals 1 over x plus 1, where x is less than -1, 2x minus 3, between -1 and 3, but equal to 3. And we have a square root of x minus 3 minus 2 when x is greater than 3. So again, let's look at, this is the y, that's the y, or the f of x. And see if I got them 1, 2, 3, oh, I got them numbered right this time, 1, 2, 3, 4, negative. And everything is okay, I got them numbered correctly this time. So let's look at y equals 1 over x plus 1. Where x is less than -1. So what do we have here? Well, we can do a table of values, and we're going to start at x is 0, x is x and y. So x is -1. So when I put a -1 in here, I get a 0. So that's undefined. So with this graph at -1, and -1 is undefined. So nowhere in this graph can we, and we sometimes put a vertical asymptote like that, but that's dotted line is just there to show you that nowhere on this graph will this piecewise function pass through this vertical line at x equals -1. So really, this point, there's no point here. There's no point that I can plot to make it. It doesn't exist. I can't put a hollow dot on any of the points up and down this line. Okay, now what happens when you have less than -1 is -2, -3, -4, etc. So we take -2 and put in here, and we get -1, so 1 over -1 is -1. Put a -3 in here, we get a -2, so we get a -1/2. And we got a -4, and -4 gives me -1/3. So in this function, notice this is the vertical asymptote. So when you go towards the vertical asymptote, it will go up alongside like this if it goes up this way, or it'll come down here like this. So -2 gives you -1, so it's right there. -3 gives you -1/2. -3 is -1/2, which is right here. -4 is here, gives you -1/3. So note, as x goes to infinity, this fraction goes to 0. So there's a horizontal asymptote right here. So this graph is goes along this vertical asymptote, going along by this horizontal asymptote. There it is. Horizontal asymptote is the horizontal asymptote for here is y equals 0. So it's going along by this. Now let's look at the other side part of the interval. So we look at -1 less than x less than or equal to 3. Okay, x and y. So notice this is a linear. Y equals mx plus b with a y-intercept of -3 with a slope of 2 over 1, so it's a line. So this is the part of this line. So if we look at it, this line has a y-intercept of -3, and it's going up 2, right 1. So it's starting here, and it's going this way, up, right here, up 2, right 1, up 2, right 1. So it's going up from like this. But that's if you did the whole line like that. With this y-intercept of -3 plotting it, it will go through here doing this. But we only take this part from -1 to a 3. So -1, 0, 1, 2, 3. Let's put these points on this interval. -1 going in here, -2 minus 3 is -5. 0 going in here gives me -3. 1 going in here gives me -1. 2 going in here gives me 4 minus 3 is 1. 3 going in here gives me 6 minus 3 is 3. So we have this interval. So -1 and -5. So it can't have this point right here. So I make it hollow because nowhere it can't have it. So -1, -5. There's a -5 there. 0 is -3 right there. That's, as we said, this is the y-intercept of -3 right here. 1, -1. 1 is -1. 2 is 1. 2 is 1. And 3 gives us a 3. So 3 gives us a 3 right here. But this point, again, is equal to 3. So it's equal. This point is included. So it's a solid dot right here. This is the hollow here. And so notice when we start here, we go up 2, right, the slope is 2 over 1, so we go up 2, right 1, up 2, right 1, up 2, right 1. Or we go this way, if we go up to the right, we can also go down, which is negative, to the left is negative. So this is part of this line. There it is there. It's hollow here and it's solid here. And we have one more, so y equals square root of x minus 3 minus 2, and the interval is x is greater than 3. So what does this interval? Well, the square root is the inverse of a square. So a square is a parabola that goes up or down. So this comes off the inverse. This is y equals x squared. So its inverse of this is y equals root x. So this was a parabola, but its inverse is turned sideways, so it's going sideways. So a parabola would be doing like up or down, so we take it, do that. So this is a piece of this going sideways. So it's either take this piece going like this, or you take this piece which goes down here. Anyway, this is a half of a parabola going sideways. So knowing that the square root is a graph that's going, instead of up and down, it's going sideways, top or bottom. So we're looking at x is 3 and greater than, we look at a 4, we look at a 5, we look at a 6. Let's see, notice that this is a square root of this number is positive, so that means it's going up, it's upward. And if you think about it, right here, this point that it starts at, peak point, I won't say vertex, it's not a vertex, it's the starting point. So this starting point is that when x is 3, y is negative 2. So 3, put 3 in here, you get a 0, which gives you negative 2. So this is the starting point. And again, now when I put the values of x greater than 3, put a 4 in, I get 1, square root of 1 is 1. So 1 minus 2 is negative 1. Put a 5 in. Put a 5 in here, I get 2. Square root of 2 minus 2. That's root 2 is 1 point something. So it's a negative number. And if I take my calculator and work out the square root of 2, I think what is the square root of 2? All right, just to check it out. Square root of 2 is about 1.4. So I get the square root, it is 1.4 minus 2. So that gives me a negative 0.6. Okay, I put a 6 in. Now I can keep on going, put a 7 in. Now I put a 7 in is better than a 6, because if I put a 7 in, I get a 4. Square root of 4 is 2, I get a 0. So that's, try to put numbers in here. That'll give you perfect squares. So here we go. In the graph, 3 gives me a negative 2. So 3 is a negative 2 right here. And this point is not included because x is not equal to 3. Now remember, we said it's positive, so it's going up sideways. So 4 gives you a negative 1. So 4 gives you negative 1. Again, 5 gives you negative 0.6. So there's a negative 0.6 right there. And 7 gives you 0. So 7, 5, 6, 7 gives you 0. So here it is here doing this. Again, square root is the inverse of a parabola. A parabola goes up and down, so a square root goes sideways. And it's going sideways from this point upward, and the table of values illustrate that. Just wanted to do a few extra graphics, and you see that I've introduced this concept of rational functions, where your denominator, if the denominator can't cancel out by a common factor, then we have vertical asymptote. Okay, that brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.